Hey folks, welcome back for another episode of Code Club. In the last two episodes, you'll recall that I did some recreation of plots that were published by the Pew Research Center in this article titled Americans Expect Corporations, the Wealthy, White People, and Other Groups to Gain Influence Under Trump. In the last episode, I recreated this figure, and then 2 episodes ago, I recreated this figure. And I've talked a bit about why I don't like this figure, mainly because the not be affected group is difficult to compare across the different categories, right? Because there's no common reference point either on the left or on the right. In fact, the lose influence doesn't really have an anchor point either because it's a bit jagged here. It's not so bad, but anyway, this is a common problem with stacked bar plots, is the lack of a decent number of reference points to compare the size of the tiles or the rectangles across different categories. Another problem with stacked bar plots is that people tend to have far too many categories within each stack, making it difficult or impossible to differentiate between the different colors. Of course, there are only 3 colors here. That's not so bad. I liked this version better because it pulled out the not be affected group and gave them a common left reference point. And of course, gave the lose influence and gain influence a common reference point as well. And so this configuration makes it easier to compare lose influence across categories, gain influence across categories, and not be affected across categories. What it does a poor job at, though, is helping you to compare within a category across the 3 groups. Yes, some things are obvious, like white people, very low likelihood that they'll lose influence, high sentiment that they will gain influence, and a decent level of expectation that they'll not be affected, whereas, say, transgender people are the complete opposite. At the end of the last episode, I made a proposal for a third way of visualizing this type of data. This is the way I prefer to view my own relative abundance data, where I'm looking at different taxa of bacteria appearing in different groups or different samples or different treatment effects in my data set, rather than, again, using a stacked bar plot. And that would be to use a dot plot. So that's what I'm going to do in today's episode. We are going to convert this into a dot plot. I'm not going to convert it so much as start from the beginning, but you'll get the idea if you compare and contrast the 2 videos. Basically, within each of these categories, I'm going to have 3 points. The 3 points are going to be 3 contrasting colors. 1 color going with lose influence, 1 color going with gain influence, and 1 going with not be affected. This will then allow us to compare within a category the 3 effects, and then to compare across all the categories the 3 effects, okay? So that is the plan for today's episode. I'm largely going to take the approach that I used in the last episode to recreate this, and so we will start with that data. I have a gainers and losers R script here in RStudio already opened up. If you want to get the code that I'm generating over the course of this episode, down below in the description for this episode, like all of my episodes, you'll find a link to a blog post where you can get this code. I am starting with loading the tidyverse, showtext, and ggtext libraries. The tidyverse gets us all the great stuff from dplyr and ggplot2. Showtext allows us to bring in fonts like Libre Franklin and Gelasio. And then ggtext allows us to bring in Markdown, HTML, and CSS styling to improve the appearance of our figure. Let's go ahead and load these libraries and our fonts. And then I have transcribed from this version of the plot into a tribble so that I now have a data frame, a tibble, that has a category column, a lose column, a gain column, and a none column. All right. Finally, I have a ggsave statement that is using the same aspect ratio of this plot over here. So let's go ahead and assign our tribble to an object that we'll call data. And that's loaded. So the first thing I'm going to want to do with data then is to pivot it longer. We have these 3 columns of lose, gain, and none with their percentages for the different categories. Ultimately, what I'm going to want to do is take the category and map that to the y-axis, the percent to the x-axis, and then the color to the effect, right? And so maybe actually I'll do that back up here with this tribble. And so we can convert that using pivot longer. So we'll do pivot longer, and we'll do minus category. So we'll pivot everything but the category column, and we'll do names underscore to effect values underscore 2 equals %. And so then again, if we look at data, we see that we've got the category repeated 3 times because we have the 3 effects and the 3% values. Then what we can do is go ahead and pipe this into ggplot. And as I said, for our aesthetics, on the x-axis, we'll do %, our y will be category, and then our color will be effect. And then I'm going to do geom underscore point. This is the idea, right? We have the categories, and then we have points for each of the different categories. And of course, we have the categories are being alphabetized. By default, ggplot2 will alphabetize categorical variables on our axes. And so that's what we're seeing with Asian people at the bottom, younger people at the top, whereas they have business corporations at the top and people like yourself. They've basically stratified the different groups according to, the level effectively of if they'll gain influence or lose influence or not be affected. So let's go ahead and incorporate that ordering. And we can do that back up here with our data by doing a mutate on category to be a factor on category. And the levels will be category, right? So we're basically taking the category column, turning that into a factor, making it ordinal data. And then we are going to set the order of that by the current order in the data frame. And then we can then pipe that into pivot longer. Actually, you know what? I don't even need to make data. I think, have a single pipeline without assigning anything back to data. Let's see how long we can get away with doing this. So now we have business corporation at the bottom, people like yourself at the top. This should actually be business corporations. It's got an S, and it should be at the top. So let's fix both of those things. So again, we'll make business corporations. And then to flip the order, I can wrap category with the rev function. And the rev function reverses the order of things, right? So if I have the vector 1 to 10, that gives me the numbers 1 through 10. If I do rev 1 to 10, then that gives me 10 to 1. Cool, eh? So now when we run this, again, we get business corporations at the top and people like yourself down at the bottom. I like having the break in the 3 different groups as well as the people like yourself. It kind of highlights what I'm supposed to see as being people who we think are going to gain influence, lose influence, and perhaps be more moderately affected. To do that, what we can do is add some dummy variables to our Tibble. So after evangelical Christians, I'm going to go ahead and create a category I'll call dummy1. And so I'm going to have dummy1, dummy2, dummy3. And that's because we can't have redundant category names when I'm doing this factor category levels equals category bit, right? Because you can't have duplicate names. And so I'll give them dummy1, dummy2, dummy3. Don't worry, we're going to white out those names and we're going to not see the points. So we'll do 0, 0, 0 for dummy1. And then let's go ahead and after Asian people, we'll have dummy2. And then before people like yourself, we'll have dummy3. So now we have dummy1, 2, and 3. And we have what appears to be a blue dot, but really all 3 dots are right on top of each other here. I don't want to see the dots, and I don't want to see the label. To get rid of the label, I'm going to use a span with element markdown to turn the text for dummy1 to be white. So it basically blends in with the background. For these points, I think what I'll do is give them a negative percentage value. So maybe -5. And then I'll use chord Cartesian to hide them, okay? So let's start with the point. So instead of all those zeros, let's go ahead and make it -10. And so we'll go ahead and insert that. And then I'll go ahead and prepare for my dummy1 to get whited out by doing span style equals single quote color :white close quote close brace. And then we'll also go ahead and close out the span. And so I'm going to go ahead and copy this down for dummy2 and dummy3. But of course, I've now changed it to dummy1. So we need to rename it to dummy2 and dummy3. And we've updated the percentages on all those. And so now we see that we've got those titles in and that our points are at -10. So now we need to do 2 more things to get the break in the data. To hide the text, we're going to use element markdown. So let's start there. So down here, we'll do theme. We'll do axis.text.y equals element markdown. That then whites out those titles, right? Now to get rid of that point, we're going to go ahead and set the x-axis to go from, say, 0 to 90. Maybe we'll go from 0 to 100 and see what that looks like, okay? So after geom_point, I'll do chord Cartesian, I'll do expand equals false, and I'll do clip equals on. On is actually the default. What on means is that it will clip. It will remove anything outside of the plotting window. Then we'll do xlim equals c, and this is going to define the limits. So we'll go 0, 100 to add that in. And what this should do then with this syntax is hide those 3 dummy variable points. We now see that we no longer have the dummy data, but what I'm noticing is because we turned off the expand, people like yourself at the bottom and business corporations at the top are getting clipped, right? So let's go ahead and expand the y-axis. So I believe people like yourself is at 1 and business corporations is at 21. So let's go ahead and add to this then ylim equals c, and we'll do 0.75 and 21.25. Yep, and I got a comma instead of a period. And so that then gives us our own artificial expand on the y-axis, and I think that's pretty nice. So let's go ahead and get rid of the ticks on the y-axis, and maybe we'll also get rid of the ticks on the x-axis to clean things up a little bit. So we'll do axis.ticks element blank. That gets rid of those tick marks. Let's also go ahead and bring in our Franklin font. And so we can make the default font for the theme to be Franklin by doing text equals element text, and then do family equals Franklin. So thinking about the plotting panel here and what I want it to look like, let's go ahead and remove it and go from there. So let's do panel.grid equals element blank. And before I do that, I'm thinking about basically drawing skewers through all the points. And I'm wondering if I want to leave that in, but I don't think I do, because it's going to give me a grid line where I have a blank, right? And I think if I use geom_line instead, I can control where those horizontal lines, where those grid lines show up. So I'm going to remove the grid line, and ultimately we'll add back a grid line though using geom_line. So I like that. And then we'll also do panel.background equals element blank. And I think I misspelled panel. All right, let's get that right. That cleans that out pretty well. Let's then go ahead and add the skewers, and we can do that back up here before geom_point. I'll do geom_hline, and we'll do y-intercept, and I'm going to do 1:21, and let's add that in. And so that gives us a solid black line for everything, which I said I didn't want, right? So let's go ahead and customize that a bit more, right? So instead of 1:21, let's use the C function, and we'll do 1, 3, 4, 5, 6, 7, 8, 9. And then we're going to skip 10 and do 11, 12, 13, 14. And then we'll skip 15 and do 16, 17, 18, 19, 20, and then 21. So we could simplify this by doing like 3:9, 11:14, 16:21. And so now we have the skewers for each of the groups. All right, let's go ahead and maybe make that thinner and less pronounced. So in geom_line, of course, we can do line width equals 0.2. Color, let's make it a dark gray. So we'll do gray 40, and that gives us those nice clean lines. Let's go ahead and clean up our Y and X axis labels. I think I'm going to remove category and maybe make percent capitalized with the percent sign. So we can do that up here. Maybe I'll do that before chord Cartesian with labs. So for X, we'll do percent with the percent sign. And then Y, I'm going to remove it, so we'll make that null. So I feel like this is coming together nicely. Before I go ahead and put in the titles, I want to turn my attention to the colors. We have red, green, and blue. So red and green are bad just because a decent fraction of the population can't differentiate between red and green. I would rather have 3 contrasting colors with none being a neutral, gain being a positive color, and lose being perhaps a more negative color. So a resource that I really like to consult is ColorBrewer2, and so colorbrewer2.org. It allows you to insert things like the number of classes. So we have 3. Whether you want the colors to be sequential, like this, diverging, or qualitative, where you'd have 3 different colors, which is basically the color scheme we have here. So let's go ahead and pick a diverging color scheme. And we want to be careful to avoid colors that are affiliated with like the political parties. Let's look at the different options, right? And so there's this. I'm just going to kind of look at some of these. So that's, again, kind of the Republican Democrat appearance. This has kind of 2 neutral colors like white and gray. Gray is a kind of a shade of black. We also want to be careful about not associating black with being negative, right? So this is more of an orange and a light blue. I could get behind that. This is like a green and yellow and an orangish color, right? So I could see using this orangish color to be kind of like slow down, this greenish color as like speed up, like a positive sign, right? And then maybe instead of this yellow, what we could use would be a gray color. So I think I'm going to go with that. All right, I'm convinced. And of course, we might change this later. Let's do scale, color, manual. So let's go ahead and do breaks, and we'll do lose, none, gain. We might need to make this into a factor. I forget what's going to happen if I set it like this. Really, all I care about is the order in the legend. I don't care about the order of the points. That doesn't make any sense. And then we'll have values, and we'll have a vector of 3 values. And so for lose, I said we would use this orangish color. And so that's going to be this here. Gain then will be this greenish color. Plop that in. So for the gray, let's go ahead and just use the keyword gray, get a plus sign here. And then for our labels, we'll do lose influence, and then not be affected, and then gain influence. And then we need a comma up here. And so we have lose, not be affected, gain influence, and then we've got our colors there, okay? So those colors aren't super bright. Maybe what we could do is make the symbol a bit bigger. So let's go ahead, back up to geom point, and we could do like size equals 2, and that makes them a bit more pronounced, and we don't have to worry so much about the points overlapping on each other. I think that's pretty cool. Let's get rid of the title for our legend, and we can do that either in labs or in scale color manual. Let's go ahead and do it in labs. So we'll do color equals null. Of course, then that gets rid of the title. I would like to put a box around my legend and move it into the plotting window because we have all this white space on the right side of the window. Let's go ahead and add a border around our legend. So we'll do legend.background, we'll do element rect, and then let's do color equals, and I'm going to use that gray color that we used up here, which was gray 40. And then our fill, I'm going to make that white so that it's an opaque background. All right, so that then gives us a border. Let's go ahead and shrink down the separation between our keys and labels. And I'm pretty sure that we can do that with legend.key.size. And we'll then use unit, and let's say 5 points. And so, yeah, that collapsed that down pretty well. Let's see what 10 does. So I think that got a little bit more breathing room. There's a bit of I think, extra margin around the text inside of the box. So we'll shrink that with legend.margin equals margin. And then let's do 3 all the way around. So maybe we can make it 2 on the left and 5 on the right. So T, R, looks like that 5. Bottom left, let's make that 2. And I think that looks better. Let's go ahead also and make the border a little bit thinner. And so that will also be, I think, in here within legend. I think that'll be within legend background. We can do line width equals 0.3. And I think that gives it a pretty simple, elegant appearance. All right, so let's move this into the plotting window. All right, so now what we can do is legend.position equals inside. And then we can do legend.position inside equals, and then we give it a vector of values. And let's do like 0.8, 0.6. So let's move it 80% over on the x-axis and then 60% up on the y-axis. And so that then moves that up into our plotting window. One of the things I like about having that border is that it then basically says, these go together. These are part of the legend, right? And with the white background, we don't see anything behind it, right? One problem is that our right-hand margin is clipping off the 100%. So let's go ahead and add plot.margin equals margin, and we'll do t equals 10, r equals, let's do 15, b equals 10, and l equals 10. And now our 100 isn't getting clipped. All right, so I think as a core figure, this is looking pretty good. Now let's go ahead and add the titles like what they had in the original. I will go ahead and copy this for the title and subtitle. And coming back up to labs, we'll add title equals that. And then we have a line break here. So I'll use the BR for a HTML-based line break and bring up the rest of this. And then we need a close quote at the end of the title with a comma, and then a subtitle equaling this. And I believe the will has a couple underscores after it, right? So we'll do 4 underscores, bring back up the in Washington with Donald, and then a line break, Trump, right? So that should get us our subtitle. For some reason, my indenting is being weird. That cleans it up. And as we have seen, this then justifies the title and subtitle on the panel rather than on the plot. I also don't have my caption yet, but let's worry about the title and subtitle first. And so then we can do plot.title.position equals left, and we could do plot.title equals element markdown, and we'll do face equals bold to make it that bold font. And then we'll do plot.subtitle element markdown and face equals italic. So the way I'm doing this, I actually don't need to use markdown. I do have the BR anchors up in the text. I could just as easily use a \n and then use element text here. Whatever. I think this will be fine. You could do it either way. All right, I'm getting an error. Plot title position must be one of panel or plot, not left. I'm getting tired. Plot. So now that's got that left justified. And our subtitle also needs to be the Gelasio font, which was that serifed font. So we'll do family equals Gelasio. Before we worry about formatting things further, let's go ahead and add in the caption down here at the bottom. And we'll add that with labs as well. So we'll do a comma, caption equals that in quotes, and then we'll do the BR. There's a bit of a weird spacing between the line that starts source and the line that starts with the Pew Research Center, right? These aren't evenly spaced, but that's not quite a double space. So let's go ahead and around Pew Research Center, let's go ahead and put 2 stars around that to make it bolded, whereas the rest of it is going to be a regular font face. So we've got the stars there, but we see it's right justified on the panel rather than left justified on the plot. So we'll come back in here and we'll do plot.caption equals element markdown. So in this case, we do need the element markdown because part of the caption is going to be a regular font, part of it is going to be a bolded font, also part of it's going to be gray, and part of it's going to be black. So let's start here with element markdown, and we'll also do hjust equals 0. To get it to be left justified on the plot, there's another position argument. We could do plot.caption.position equals plot, not left, plot. And so now what we see is that we have it left justified, but as we have seen, we need to adjust the line spacing of our various titles and captions. Let's go ahead and increase the line height on our title. I like the font. I think that's a pretty decent size. So in here in plot title, we can do line height equals 1.3, and that gives it pretty good separation. And then around our subtitle, we need to add some margin, but we also need to shrink down the font. So let's go ahead and shrink down the font and make it gray. And so we'll come in here and we'll do color equals gray 50. And let's also then do size equals 10. And so that does a pretty nice job of bringing it in and making it lighter. Let's add some line height to it to get a little bit of separation between those lines. Line height. And let's do 1.3 again. And that's pretty good separation. Now let's give some margin around the top and bottom of the subtitle. We can do that here with margin. We'll do margin T, let's do 10, B equals 10. Let's maybe make it 5 and 15 to make it a little bit closer to the title, but a little bit further away from the plot. So I said 5 and 15. I think that's pretty good. I'm not trying to faithfully replicate everything that they did. I've done that in the previous episodes. You can go back and look at that if you want. Now let's turn our attention to the caption here, right? And so this also needs to be gray for the note and the source lines. And then I should probably change this instead of Pew Research Center. Maybe I'll do like Riffomonas Research Center. Yeah, so instead of Pew, we'll do Riffomonas. And we'll also want to wrap Riffomonas Research Center in a span to make it black, okay? So we'll do style equals and single quote color colon black, single quote, close out the span, and then back here / span. So that gets Riffomonas Research Center in black. We want the rest of it to be in gray though. So let's come back into plot caption, and here we can then do color equals gray 50. That makes it a nice light color. Let's go ahead and separate those lines. So we'll do line height equals 1.3. So I think that's pretty good. Maybe we could shrink the font a little bit, and we'll go ahead and do size equals 10. That's big. Let's take that down to say 8, and I think that's pretty good. Let's go ahead and maybe add a little bit of spacing between the caption and the rest of the plotting body. And so to do that, we'll again use margin. Okay, so we'll do margin T equals, let's do 15. And that gives it a bit of a bump up. So 2 more things that I want to do would be to maybe tweak the colors. I mentioned the thing about red and green color blindedness, and then I picked colors that are red and green. What was I thinking? Anyway, let's go ahead and look back at our color brewer. And I think I would prefer to do something like purple and green. We could still have green be gain influence, but maybe make this purple be the lose influence. So I'm going to go ahead and grab that hex code, and then I'll plop that in for lose influence. And I think I'll also grab this green. I think it's a slightly different hex code than what they had. So I do like having that green for gain. Green kind of means go, right? And so the purple is perhaps a more subdued, slower color. I don't know, maybe I'm reading too much into it. Anyway, the other thing I'd like to do is maybe move up our legend a little bit to kind of overlap with the gap area a little bit more. It just seems kind of weird hovering right above this line. And maybe if it was fully over the 2 lines, it wouldn't look so weird to me. So again, we did that up here in legend position inside. And so the first was 0.8, that's the position on the x-axis, and then 0.6 was on the y-axis. Let's take that up to 0.7. And so that moves it up maybe too far for my liking. Let's take that down to 0.65. All right, let's take it down a little bit more to 0.63. So on the whole, I really like my version of the plot. Maybe we're not totally sold on the colors at this point. Again, what this allows us to do is to interpret the data in a variety of different modalities, right? So first of all, I can look within each of the categories to make a comparison, right? So business corporations, I can see lose influence and not be affected are relatively low, whereas gain influence is rather high, right? And so it's very easy to compare within a group. And we can see older people, you know, it's a mixed bag, right? Same for younger people, right? Asian people, perhaps, they're not thought to gain too much influence, but you know they're equally likely to not be affected as to lose influence, right? But then also, of course, like transgender people, we can see that most people think they're going to lose influence rather than gaining influence or not be affected. The other thing it allows us to do that we could also do with this version on the left is I could take this purple dot and I could basically trace this purple dot all the way across to see what groups and in what order are going to lose influence, as well as gain influence, or with this green set of dots, or perhaps not be affected with this gray set of dots. So 2 things you might quibble with me about might be the amount of separation between the 4 different categories. The way I did it by inserting a dummy variable, I don't have a lot of control over how much spacing there is. So if you think there's too much space or not enough space, then maybe we should have used facet wrap or facet grid to create the 4 different panels, and then use the panel spacing argument in the theme function to change the amount of spacing between the 4 panels. The other thing, there might be such a large vertical distance between, say, business corporations and people like yourself, that people might think, well, I can't quite trace where 25 is here, right? Or 50 or 75, right? I don't think that's such a problem, because I think a lot of this variation is qualitative and relative, right? Kind of thinking about transgender people really have a sense that transgender people are going to lose big under the Trump administration, right? And I don't need to know what this value is, but I can see that it's so much further to the right than everything else, right? So in that way, we can interpret this in a qualitative manner. If you were to add vertical grid lines, I think that would kind of busy up the plot a bit. I'm not totally sold that you would need it. Maybe there is too much separation here. Perhaps that does make an argument for using something like facet grid, where we can control that separation between our panels. I would really love to hear your opinion of which of these 3 different ways of visualizing the data you like best. Again, on the left, we had the stacked bar chart. On the right, we kind of had the stacked bar chart for lose and gain influence, but then we pulled the not be affected out to the right. And in the third approach, we used a dot plot. Again, let me know what you think. I feel strongly that the one on the right is the best version of these 3 different approaches, but you'll have to let me know what you think. Alternatively, if you have ideas for what would make any of these better, I would love to get that input as well. Please put your comments down below in the comments of this video. Hopefully over these 3 videos, you've learned a lot about ggplot2 and how you can take very similar data or the same data and make very different plots that vary in the complexity in which we interpret them, with which your audience members will interpret the data. Ultimately, we want to make things as easy as possible for our audience to understand the message, the story that we're trying to communicate. Well, that's all I have for today. I would love it if you gave this video a thumbs up, as well as subscribe to the channel. What would be even better would be if you told all your friends about all the great stuff we're doing here on these videos. Anyway, keep practicing with these concepts, and I'll see you next time for another episode of Code Club.